Everyone, welcome back. Yesterday we have solved edit distance problem and I have posted the video on my YouTube channel where we have explained how to approach this problem in top down and bottom up approach, and we also analyzed that the time and space complexity for the top down and the bottom up approach is big of m into n, and we also noticed that there is a scope to optimize the space complexity in the bottom up approach, right? So today I will be explaining you how we can optimize this. Okay, if you see at any given point, my answer to my I and j is relying on I plus 1, j plus 1, or I j plus 1, I plus 1 j, I plus 1 j plus 1. Okay, if you see, it is only depending upon the next row or the next column. Okay, so do we really have to maintain m rows, right? So it is not really required because I only require what was previously calculated. Let's say I'm processing the ith row. If I know what was previously calculated, which is I plus 1, because in the bottom up approach we are first calculating m minus 1 and then going to m minus 2 and so on and so forth. So first we'll be calculating I plus 1 row and then we'll going to I and I minus 1 and so on and so forth up to 0, right? So at any given point when I'm processing I should know what was previously calculated, what was the answers to my previous row, right? I only require 2 rows. So when I'm processing this row, okay, I will be referring to I plus 1 row, right? And I will be populating all the values for ith row. Now when I will try to process for I minus 1 row, instead of having a separate row, I will straight away update my answer in I minus 1 row itself, I plus 1 row itself. Okay, so using these values I will be filling this row, and this will become previous row for the next computation, and this will become previous row for the next computation. I will be filling this row. Now once this row is populated, this will become previous row for the next computation, and this will become the current row, and so on and so forth. Okay, at any given point I have to flip what is current and what is previous, right? So for sure I require only 2 rows, right? I need 2 rows. Now as I mentioned, I have to flip between two numbers, right? Either it could be, so when I have to flip between two numbers, I will, let's say I only have 0 and 1 as my number. Okay, I will say 0 and 1 are my numbers, and if I have to flip between these two numbers, how can I do it? I can simply take a number divide modulo 2. This will always make sure the number will always lie between 0 and 2, right? So m modulo 2. Okay, whatever the row I am trying to process, I will do modulo to it. Okay, now instead of filling all the last columns, okay, so I have to populate the column whenever it is required, right? So this I will be moving down here, and when I am processing I minus 1 row, I only have to populate the last column of that I minus 1 row itself. So that is what I am doing over here. Now again I will be, wherever I have I will be doing modulo to it. Okay, modulo 2, simple modulo 2, modulo 2, modulo 2, and then modulo 2. Okay, and then my answer will lie in 0 comma 0. 0 comma 0. We only have two columns. Okay, let me just remove this. Okay, so if I try to submit this problem, it has to work. Let's just validate it. As you can see, all the base test cases were passed, and if you try to submit this problem, as you can see, all the test cases were passed, and you can see the space complexity has been optimized rapidly. We have already beaten 99% of people over here. Okay, let's analyze what was the space complexity. Okay, so we are only having 2 rows with n plus 1 columns, okay, where 2 is constant, right? So we can, in terms of big O notation, we can say we have reduced our time complexity from big O of m times n to big O of n, right? So this is one optimization where we have reduced from big O of m plus n to big O of n, where we are using two rows, right? Now instead of using two rows, we can also use one single row and still we will be able to solve this problem. Okay, so I will also show you that approach. If you are curious enough to solve this problem using one single row, pause the video and try to solve it. Okay, so let's say answer to I plus 1 was already computed and stored over here. Okay, now answer to I, if you see, the answer to ij is only depending upon I plus 1, j plus 1, I j plus 1, I plus 1 j, I plus 1 j plus 1, right? At any given point it is only relying on its next row and the next column, right? If I am trying to compute answer to this ij, it is relying on this, right? Only these three it is relying. So can we do anything better, right? So instead of storing the values in the next row, can we override the values in the existing row itself? Okay, and if you see the pattern in which we are populating our answer, the j values are getting populated from n minus 1 to 0. Okay, so this is the direction in which we are actually populating the answer or overriding the answers, right? So if you see answer to ij is depending upon this value, the diagonal value, and these two values. So since we are populating answer in this direction, I know answer till here is already computed in my current in the next column, and answer to this is already calculated in its down column, right, which is actually the same row j value. Okay, pay attention over here, this is very important. Okay, so answer to j plus 1 is already computed because we are computing in this direction. If I am trying to compute answer to this, so j plus 1 will be containing answer to the previous column. Okay, now before overriding this value, I should also retain this value. So before overriding this, somehow I should retain this value. So what I will do, I will just store this value separately so that this value is getting overridden with this new value, and this value is also retained at some place so that I can get the diagonal value to this. Now answer to this is relying on answer to the down value, which is already present here because right now we are computing this, we haven't overridden this yet. Now answer to this also depends on the next value which we have already overridden and stored it here, and answer to the diagonal value we have stored it separately, right? So using this we will be computing the answer and storing it. So before storing this, we should also retain this value. Okay, we should also retain this value for the next next calculation, because this will become, if you override the value at here, this will become diagonal for its previous column again. So at any given point we should retain the value in the down. Okay, we should retain the value in the down, which will become the diagonal for the next column or the previous column, right? So that is the key idea. Okay, so let me jump dive into this problem and show you how we can optimize it. Okay, so as I mentioned, we only required one row and we will be filling answer for the last row. That means answer to convert to empty string to s2 is basically this, right? Now as I mentioned, I need a variable to keep the diagonal value. Okay, so let's say before overriding the value itself, as I mentioned, before overriding the value itself, I have to retain this value, right? So that is what I am doing. Before overriding the value at a particular column, I am storing this value. Okay, once I store the value at a particular column, I can override it. Okay, now the value at the current column the value of the current column will become diagonal to its next column or the previous column. So I should also try to store the down value as well. As you can see, this is the down value, okay, from dp of j. This is the down value. So dp of j itself is the down value. I should also try to store this value. So that is what I am doing over here. Now I will just I'm just overriding the dp of j with the same recursive relation which we had. Okay, I will just remove all the rows. Okay, now if you see, okay, just a minute, if you see, this is I plus 1 and j plus 1, that means this is a diagonal value, so this has to be the previous diagonal. Okay, and answer to I plus 1 and j plus 1, so this is also coming from, this is also diagonal value, sorry, this is previous diagonal. Now once answer is already computed, okay, my down will become the previous diagonal. So whatever the down value we have stored here, that will become the previous diagonal for the next computations, and my last answer will be in dp of 0. Okay, let's try to copy this and then let's try to run the problem. Sorry, some syntax error. We have mentioned that it is 1D array over here, but we missed to correct it over here, my bad. So let's try to run this. Again we have missed to remove the rows computation. Okay, where we have manipulated the answer. Okay, we have manipulated here only, right? Okay, so we should also, we have missed to correct these values. Okay, so dp of I will become dp of j, so there are no rows, right? We only have single row, so there is no I at all, so that is we have. Okay, let's try to run this. As you can see, all the test cases were passed and basic test cases were passed. Let's also submit this problem. Okay, and let's look at this. As you can see, it has also improved in its time and space complexity. Okay, so here instead of using two rows, now we are using one single row to compute the answer, right? So this is again a better solution in terms of space complexity than the previous approach which I have mentioned. So answer, both the solutions will be posted in the description in multiple languages such as Java, JavaScript and Python. Feel free to check it out. And if you like the explanation, hit the like button and hit the subscribe button, and also share your valuable feedback in the comment section. Thank you.